Hi there, my name is Victor Wong. This is my assignment 2 for the class Data Analytics for Information Professionals, and welcome to Introduction to R. Today, I will be introducing a new tool that's commonly used in data science, known as R. So here's the agenda for the topic that we will be covering today. The scope for today will be divided into 5 parts. Part 1 will be the introduction to R, where I will explain what is R for, and how does it apply to data science. Part 2 is where I'll teach you how to download R. Part 3 will cover the basics of R, where you will get familiar with the language and tools offered. The fourth part is where we focus more on data analysis and data visualizations with R. This part is interesting because you'll be able to apply statistical knowledge and plot graphs. Finally, the last part will consist of the limitations, concerns, and pitfalls of R, as well as a final summary. So let's get started with the first part, introducing R. So what is R? R is a programming language and a free software environment for statistical computing and graphics. It is also an interpreted language. An interpreted language is a programming language for which most of its implementations execute instructions directly without previously compiling a program into machine language instructions. Basically, it reads the source code written by the programmer and converts it into a form which it can execute directly. Essentially, R is a software that facilitates various functions from data manipulation, statistical analysis, calculations, and graphical display. So how does R apply to you? R is a great first data science programming language. It is also one of the most popular languages for solving data science problems. R is also heavily used by data scientists in major companies such as Google, Facebook, Amazon, Uber, and so forth. It's also a great tool used for machine learning, data analysis, statistical analysis, data wrangling, and data visualization. So what can you do with R? Well, there are many functions to R, but here are 4 main reasons why people use R. The first would be data wrangling. So what is data wrangling? Data wrangling is the process of cleaning messy and complex data, which is why companies um, usually call it data cleaning. It is often performed by data analysts or data scientists before the analysis itself. Next, you can conduct data analysis through R. Some data analysis consists of basic mathematics, statistics, probabilities, modeling, testing, machine learning, and so on. R is considered a programming language, and so you can also use it for general programming. What you can do involves input and output, object-oriented programming, and distributed computing. Lastly, data visualization is a popular feature of R as it offers great insight into interpreting the data. We'll look into detail on this later. So part 2 of this lecture will be on how to download R onto your computer. There are 2 options to downloading R. You can choose to download the R console, which is simply the console where you type your commands and get output. The other option is R Studio. R Studio allows the user to run R in a more user-friendly environment. Because R Studio is more user-friendly, for this lecture, I will be teaching you how to download R Studio. As seen, I have provided the links to downloading R console and R Studio. So if you could, please click on the second link. However, if the link does not work, you can always Google R Studio and it should look like the option that is circled in red. Click on that link. Once you have clicked the link, you should be directed to their homepage and it will look like this. To download R Studio, click on Download R Studio, which is circled in red in this picture. Upon clicking on Download R Studio, you'll be directed to this part of the page in which you should choose the free version. Click the download button that's circled in red. After clicking on download, you should see all the available installers. R is a cross-platform language and so is compatible with many operating systems. If you're using Windows, please click on the first link, or if you're using a Mac, please click on the second link that is circled in red. Once you're done, it should download and the setup will pop out. Click Next. Wait for it to install and then click Next and Finish. Once it's done, simply open R Studio on your desktop. So this is how it will look like on Windows. And if you're using a Mac, this is how RStudio is displayed. Now that we have RStudio installed in your computer, let's have a look at what RStudio offers. On the left, you can see a large box which is essentially the R console. The console is where you'll be working on. It is a place for typing commands and getting its outputs. On the top right, you'll see the environment and history box. The environment is also known as the workspace tab. The workspace tab is where you can view all active objects, while the history tab is where you can view previous commands. Lastly, the bottom right shows several tabs. The File tab shows you all files and folders on your PC. The Plot tab will show your graphs. The Packages tab shows the available packages to run additional processes. The Help tab works like a dictionary, where you can basically look up additional information. Moving on to part 3, which is basics of R. The subtopics of this portion includes calculator, variables, vectors, and matrices. The most basic feature of R is that you can use it as a calculator. All you need to do is type the equation in the console and press enter. These are a few symbols for doing basic math. There's addition, subtraction, multiplication, division, exponentiation, and modulus. I will show examples using these symbols in a bit. Additionally, the hash symbol can be used to comment on the console. It is written at the beginning of the line. So if you were to write hash 1 plus 4, you would not get an output. So why do we comment? Well, it's good practice to comment your code so that you can trace it back easily and also to recall what that specific code was for. So here are a few examples that you can try typing in your console. For example, 3 plus 5, you will get 8, 12 minus 4, and you will also get 8. 2 multiplied 10 is 20, 100 divided 25 is 4, 2 to the power of 5 is 32, and 100 modulo 32 is 4. In case you are wondering, modulo is the remainder of the division. Next up is variables. So what is a variable? A variable allows you to store a value such as 5 or an object. To elaborate, an object is a data structure having some attributes and methods which act on its attributes. Class is a blueprint for the object. To create a variable, we assign a value or object to a variable of your choice. For example, x equals to 21 or var underscore 1 equals to 10. Do know that in R, equals is represented with the arrow. So when you type x, it will print out the value 21. You can also add variables together. For example, x plus var underscore 1 and you'll get 31. You can assign this result to a new variable. For example, new underscore var equals x plus var underscore 1. Attached below is a screenshot to how it will look like in the R console, as well as in the Environment tab. It is also important to know that the types of variables that you're dealing with. Decimal values are basically numbers with decimal points and are called numerics. Natural numbers are integers like 2, 5, 300, and 5,000. They are also numerics. Moreover, there are also Boolean operators like true or false, and, or, not, which are based on logic. There are also characters, which is usually in the form of text or string values. Examples include words enclosed in quotes like analytics, prediction, science, and so on. Additionally, you can check the data type of your variable by using the class function. Provider here is an example based on the previous variable assignment. So if you type class var1, you will get an output that says numeric. After variables, we move on to vectors. Generally, vectors are defined as having magnitude and direction. In R, it is easier to think vector as one-dimension arrays that can hold multiple values. This is different from variables as vectors can store multiple values while a variable can only store one value. To create a vector, we use the concatenation function C parentheses and place the elements separated by a comma. For example, we can create a vector called numeric underscore vector and assign it C parentheses 1, 50, 200 parentheses, or Boolean vector and assign it C true, false, true, and attached below is a screenshot to how it will be displayed in the R console. There are also many shortcuts to creating vectors. You can create a vector with equal spacing by using the sequence function. Here is an example. Vect1 equals sequence from 1 to 4 by 0.5. To print, just type vect1. You can also create a vector of given length by using the repeat function. Here is an example of me creating a vector of my name repeated 3 times. As shown, I type the character of interest separated by a comma, which is followed by the number of repetition I want to show. Next, we have matrices. Matrix or matrices for plural is commonly a rectangular array of numbers, expression, symbols that's arranged in rows and columns. Here are a few examples of types of matrices. There's the symmetric matrix, identity matrix, diagonal matrix, and upper triangular matrix. Of course, these are not all of it, and there are various other types of matrices. To create a matrix, we use the matrix function. For example, we assign to a new matrix calling upon the matrix function and place values 10 to 15 and then comma, followed by the desired amount of rows. Here we have 3 and the desired amount of columns listed here is 2. When we call the new matrix, we get the output as shown here. There are 3 rows and 2 columns containing the numbers from 10 to 15. If you were to look at your environment tab, you can see that you have new data and it's shown neatly in the environment. You can also check the dimensions of your matrix by using the dim function. To test it out, we use the dim function on our new matrix. As seen from the output, we have 3 and 2, which is 3 rows and 2 columns. Moving on to part 4, we will cover data analysis and data visualization with R. This is where you'll be introduced to datasets, statistical concepts, and plotting graphs. To start off, we will cover datasets. Firstly, the most important step in data analysis is to import a dataset. In order to import a dataset, you first need to have data either locally on your computer or found on the internet or any other sources. Generally, R accepts various file types such as an Excel, TXT, CSV, XML, SPSS, and many others. Here are a few examples of how you can import other file types with R. If you have a TXT file, you can use the R function read.table and place the name of your file in quotations and parentheses. If you have a CSV file, you can call the R function read.csv and place the file name in quotations and parentheses. However, if you have an Excel file, you will need to install packages into R before entering your commands to import data by typing install.packages and the name of desired package into quotations and parentheses. You can also go for the alternative method where you type library read XL followed by importing the Excel file and assigning it to a new variable by using the R function read_XL. There are a few key pointers to remember when importing a dataset. It is important to always set the header to true or false. If it's true, it tells R to include variable names and false to not include variable names. SEP tells R how entries in the dataset is being separated. Here's a list of examples. SEP equals comma with quotations means that entries are separated by commas. SEP equals backend slash and a T with quotations means that entries are separated by tab. SEP equals a space with quotation means that entries are separated by a space. One example of how this is written is when you import a dataset as shown below. Here we have a new variable called stock data and we call the read.table function that has a CSV file from the internet. We also set its header to true and its SEP to be separated by commas. Next up, statistical concepts. R was originally built by statisticians for efficient statistical analysis. R allows many statistical functions such as using R functions like mean, median, max, standard deviation, variance, and range. There are quicker R functions that one can use as well. If you recall from the previous example, we assign a CSV file from the internet to stock data. In this example, let us assume that we have a dataset called data underscore 1. When we call summary of the data 1, we extract statistical summaries of the dataset such as minimum and maximum values, median, mean, first quartile, and third quartile. You can also extract more statistics by calling the R function describe. This gives you the standard deviation, mean absolute deviation, skew, and kurtosis. The skew measures whether or not the data distribution is symmetrical, while the kurtosis measures whether the data have a sharp or flatter peak near its mean. It is also useful to know that the structure of your R object. You can do this by calling the R function str parentheses to see the structure or type of your R object. These are just a few packages that you can install for data import, data wrangling, and data visualization. I would not be going into detail into the packages, but to get more additional information, you can check out the Packages tab. Next, we move on to visualizing your data. This is done by plotting graphs. A few examples of how this can be done is through line charts, bar charts, histograms, pie charts, and so on. For this tutorial, I'll be covering one example and I'll be using the line chart. Over here, I created a new vector called mi_program and gave it some random data. Feel free to follow through on your R console. To plot the graph, I call the R function plot. In doing so, you'll be able to view your graph in the Plot tab located on the bottom right of your RStudio. Next, we add a line to connect the dots and apply some color. This is done by calling the R function plot with the vector name followed by the type. We use the O for overlay to create the line. We also add col to indicate color and apply green. Additionally, we add a title here, sky. To do this, we call the R function title with main equals to sky and set its color to red as well as a font size of 4. Next up, say we want to compare two graphs. We create another vector called mlis_program and give it random data. Instead of creating a plot line graph, we use dashed lines to represent mlis_program. To do that, we use the lines function where we insert the vector name, the type O for a line graph, pch which is plot character to show a filled square for each points, followed by lty which is the line type, which we equate to 2 to represent dashed. We then set the color to blue. Next, we change the x-axis to include label points. We do this by calling the axis function followed by 1 at points from 1 to 5 and relabel it by writing spring and fall for different years. We can also add a legend to better indicate the graphs. This is done by using the legend function. As shown, we place it at the top left and introduce a CEX. The sex is the number indicating the amount by which plotting text and symbols should be scaled relative to the default. In this case, sex equals 0.8, which means it is 80% smaller. We then write the vectors followed by their respective colors, line type, and plot characters. We then label the x-axis and y-axis. This is done by using the title function followed by ylab equals total student and xlab equals intake. And with that, we have completed the graph. However, this is just a basic graph and there can be more advanced functions to better showcase your dataset in a graph. Finally, we have reached our final part, limitations, concerns, pitfalls, and summary of R. Not all things are perfect. R is no different, and just like any other programming languages, there are pros and cons. Some of these limitations and pitfalls include R having a steep learning curve. Since the learning curve is steep, people might opt for another easier programming language like Python. Furthermore, although you can extract Excel files into R, the skills learned in Excel is not transferable to R. R is also poor when it comes to memory management. This is a major limitation in R as it can very quickly consume all available memory. When your dataset includes a huge amount of variables, processing speed slows down significantly. This limits the amount of data mining the user can perform. Such cases include not being able to process or work with dataset with over 100,000 records and 100 over variables. Other than that, R has a poor documentation. If you recall, the help function, that is reflected in its documentation and it works like a dictionary and is important for packages. R's documentation is considered bad because it is misguided and is not helpful for new users. Additionally, a major pitfall of R is that it is relatively easy to redefine fundamental constants in R. For example, it includes things like pi, letters, month, dot, name, and so forth. Generally, constants are entities where its values cannot be changed. However, an example of this pitfall is shown below. When you type pi in the console, you will get its value, which is 3.141593. You can later assign to a new variable spelled pi and equate it to another number. In here, we equate it to 2. When we test out pi multiply 2, we get 4 instead of 6.284. As seen, one has to be really careful when defining variables in R. Next, we look at the concerns and ethical issues relating to R. Generally, since R is a programming language, one must understand the ethical implications of their code and datasets. With big data growing at an exponential rate, we should all remember the ethical issues related to privacy, confidentiality, transparency, and identity. Ultimately, the software tool R in itself does not impose any ethical concerns. It always boils down to how we use and manage the data. To summarize, we have learned what R is, how does it apply to us, and how we can obtain it. We also learned how to use R, from doing basic mathematical functions to statistical analysis, data analysis, and visualizations. We learned that R has some limitations, pitfalls, and concerns. So to wrap up, R is a software tool that offers statistical features and programming features that is highly sought after in the field of data science. As you can see from the picture on the bottom right, it shows the top 10 most popular programming languages. R is highlighted in red here as it is ranked in the top 6. Essentially, R is a very useful language to know for anyone who is pursuing data science. Finally, I have some recommendations for further materials to explore with R. There's Kaggle, which is a website that hosts data science competitions. There are also trending repositories for R and GitHub to expand your R knowledge. There are also online learning tutorials on RStudio. The links are provided here as well. Additionally, you can also try to search up hash #RStats on Twitter as it will offer many quick R programming tips. A book that I can recommend for beginners is R Programming for Data Science by Roger Peng. Essentially, there are a few resources that can be beneficial regardless of your level of proficiency in R. Thank you for watching. I hope that you have learned and gained insight into what R is. Goodbye.